Some functions are continuous, others are not. Here are three examples of continuous functions. F, G, and H are continuous. Some functions are not continuous. Here are three examples of functions that are not continuous. F, G, and H are not continuous. What makes a function continuous? The function f is continuous for all x in the domain. The piecewise function g is discontinuous at the two arguments x equals -2 and x equals 2. The graph jumps in value at these two x values. The graph of a continuous function can be sketched on paper without lifting your pencil off the paper. The function f appears to be not continuous at x equals -1. The graph jumps in value at x equals -1. So here's our rule. The right-hand piece of the piecewise function has the constant k as part of its rule. As k changes in value, the green ray moves up and down, like so. So we want to slide the hand cursor down to make the function continuous. We just have to put it right there. Here we have three different values for k. When k equals 4, the line is up here. The piecewise function f is not continuous when k equals 4. The piecewise function f is also not continuous when k equals 1. However, the piecewise function f is continuous when k equals -2. Exercise A. Given this rule here, what value of k makes f continuous? Alright, so we want this line to be here. This value k is the y-intercept of this line. The slope is -2, and so what we want is for this line to go right like this and hit -2 on the y-axis. So -2 here would place this line segment in exactly the right place to make this function continuous. The solution states the boundary for the two rules is where x equals -1. So we need the two rules to agree in value at x equals -1. Here's a way to solve this problem without using the graph at all. So if we could set these equal to each other at -1, we could solve for the k value of -2. Exercise B. Given this rule, what value of b makes g continuous for all x? Alright, so the point where the function might not be continuous is at x equals 1. So let's set these rules equal to each other, and then we're going to set x to 1. So that becomes 3 plus b equals -2b. We'll subtract b onto the other side. Therefore, b equals -1. If b equals -1, they will have the same value. Both of these rules will have the same exact value when x equals 1. The boundary for the two rules is where x equals 1. So we need the two rules to agree in value at x equals 1. So this is exactly what we did. We set the rules equal to each other and we plugged in an x value of 1 and we solved for b. Exercise C. Given the following rule, what value of k makes h continuous for all x? Alright, so the boundary is going to be at 2, x equals 2. So we'll have 3 minus kx equal to x minus 4k. And then we're going to plug 2 into the two rules like that. So 3 minus k times 2 equals 2 minus 4k. That gives us 3 minus 2k equals 2 minus 4k. So let's add 4 to both sides, and that gives us 2k over here. We're going to subtract 3 from both sides, and that gives us -1. K equals -1/2. The boundary for the two rules is where x equals 2. So we need the two rules to agree in value at x equals 2. So they set the rules equal to each other, plug 2 in for x, and solve, and we get k equals -1/2.